continue with infrastructure as a code itself. Okay, but today we'll be learning about Terraform. Okay, we have completed Ansible. uh, Generally we should start with Terraform, like creating a VMs and all, and after creating a VM we do configuration management. But after shell scripting I wanted to take a topic on Ansible because they are a bit related. Okay, so you already know what is infrastructure as a code. You have learned Ansible as in one of the infrastructure as a code, using code, deploying something. Okay, I mean deploying the infrastructure using code is infrastructure as a code. So let's understand the terms again. We have done this on Monday itself. So deployment. So putting a new application or a new version of application on an application server or on any server is a deployment. Provisioning, the first time whatever we do, that is creating a VM, is provisioning. Orchestration, managing multiple systems, okay, or managing multiple things is orchestration. Configuration management, okay, whatever a configuration management like Apache, Nginx or MySQL or system related configuration that we do using configuration management. And what is the difference between mutable and immutable infrastructure? Mutable infrastructure can be updated and configured anytime. Okay, we can anytime change it. Okay, but immutable infrastructure is something which can never be modified when it's deployed. Never been modified means until and unless we release a new version, test it, then only we should make any changes. Suppose version 1 of a software is applied on application server, then if you want to modify something into it, just don't modify the version 1 itself which is deployed directly on the application server. First create version 2, test it, get a downtime, or there is a concept called rolling update in which there will be combination of old and new version that we'll be seeing when we do Kubernetes and all. There deploy the second version. Okay, and then only in this way only we should do modification. That is immutable infrastructure. And what is the advantage of using immutable infrastructure? As nobody will change it during the production. Okay, there won't be any downtime or configuration drifts. Okay, imperative and declarative. In imperative will tell the system. Okay, so it is one of the concept of programming. Okay, imperative and declarative. Imperative means we'll give the step-by-step instruction of how to achieve something. In declarative, we'll just define the desired state. Okay, and it will check the current state and the desired state and will try to achieve the desired state. That is declarative. We'll just declare that achieve this anyhow. Okay, and the system will achieve it. Okay. We understood the term idempotence as well. If something already exists, do not try to overwrite it. So what is Terraform? It is one of the HashiCorp's product. Okay, and it is open sourced. But nowadays Terraform is acquired by IBM. Okay, and for commercial usage, Terraform, okay, is we'll need to pay for the license. For learning purpose, okay, for keeping it open source, Terraform is free. Okay, but Terraform has one license in which it has term that if you want to use it for a commercial purpose, Terraform should be a licensed one. Okay, and as Terraform is not fully open source, fork of it is created. Fork means a copy of it is created with some other name. The binary is the same, but the other name is Open Tofu. Okay, so that Open Tofu is nowadays very famous. Okay, and you can say popular, and people prefer that over Terraform nowadays. But I don't know what will happen in the future. This has happened recently. IBM has acquired Terraform, but the license term was already changed for Terraform. It's no more fully open source. Okay, and Terraform is a tool which we can use for provisioning the infrastructure. It can be also used for configuration management, but it is meant for a provisioner, for provisioning the infrastructure. Okay, and it uses a high level configuration language called HCL, HashiCorp configuration language. Okay, and how it works, we'll see that. And what is the advantage of using Terraform? Okay, so like Terraform, AWS has its own infrastructure as a tool called, or a provisioning tool. Okay, Azure also has its own, and GCP also has its own. Okay, in AWS it is called as cloud formation. Similarly, Azure and GCP, digital also, they not DigitalOcean, but all three clouds have their own tool for creating the infrastructure using code. Okay, but if you are using, you'll have to use AWS. Okay, if you are using Azure, then you'll have to use tool from Azure. If you are using GCP or digital, then we'll have to use their tool. Okay, but if you learn about Terraform, it can be, the means the learning curve will be same. Okay, we just need to learn Terraform, and we can use that concept, like that programming concept, anywhere. Okay, so you don't need to learn another tool of AWS, another tool of Azure, and another tool of GCP. Just learn Terraform, and based on requirement you can use it. Okay, that doesn't mean that if you create one Terraform code, that will work on all the three clouds. Okay, no, but the learning curve will be less, because Terraform can be used on any cloud. Okay, it helps us in creating an immutable infrastructure. Okay, and it is, HCL is also very easy to understand. Okay, very human friendly. It can be easily transferred to any other provider. That means we can reuse that code. Okay, so some of the other tools, as I said, Azure has ARM templates, AWS has cloud formation, Google has deployment manager. Okay, and uh, Ansible, Chef, and Puppet can also be used. Okay, but Terraform is more preferred one. Okay, because it is meant for provisioning. So when we learn about Terraform, we'll be using three commands: init, plan, apply, and when we don't need that resource, we'll be using destroy. So remember these terms. So that we'll be doing some initialization. After the initialization is then, a plan will be given, that Terraform will do this. It will create this infrastructure. Okay, so generally what happens, when the plan is created, it is sent for approval. Okay, and when the approver approves it, then only the apply is done. Okay, so in interview they will ask you, means how you deploy it. So you should say that we create a plan. Okay, that plan is approved by the senior, or you can say project manager or a DevOps architect, and then when after approval, it is applied. Directly don't tell that I did init, plan, and then I did apply. Okay, so they want to see the process. Okay, you should say that we have a proper plan, and after that is approved, we apply it. Okay, so we'll be seeing that everything. So this is a Terraform lifecycle: init, plan, and apply. And when our work is done, if we do not need our resource anymore, we can destroy it. So what are the components of Terraform? We'll be writing some Terraform configuration in .tf format. Okay, in Ansible we did it in YML format. Okay, but in Terraform we have to do it in .tf format, and as I said, it uses HCL. Okay, the HashiCorp's language itself. Okay, we'll write Terraform code. Okay, then a Terraform state file is maintained, where it maintains the current and the desired state. You can say the current state. It checks with the whatever is written in the Terraform state file. It maintains it, where details of all the infrastructure is given. It checks what is written in the Terraform TF state file, and it compares with the actual infrastructure in the cloud. The cloud can be AWS in our case. Okay, and if it sees any changes, then it will try to achieve whatever written in the TF state. Okay, so it will try to achieve the desired state. Desired state will be in the TF state. Okay, so whenever the changes are done, this file is updated. We have an exercise for this as well. And what are Terraform modules? We have seen Ansible roles. Like similarly, we have Terraform modules which we can reuses. Many people have written the Terraform module, okay, and we can reuse it. So that was all about Terraform.